Take the first question. This is already done in one of our session. Write an 8086 ALP that will copy a set of 10 bytes from memory location 1 to memory location 2 in the reverse order. Start writing the program. Start writing the program. Start. It has been taught already. In the lab also you have done things. Start writing the program now. Come on. Write the first program. Start. Why you quiet? Start writing the program.
Let me think, sir.
Think. There's no time to think. It's an exam. Right. Everything already taught. Begin. Start writing the program. First program. Start the first program. Write an 8086 ALP that will copy a set of 10 bytes from memory location 1 to memory location 2 in the reverse order. Come on. Start writing the program. There are 10 bytes of data. Take down the program. Come on. Write an 8086 ALP that will copy a set of 10 bytes from memory location 1 to memory location 2 in the reverse order. Right? Come on. How to do this? Don't look at your mobile phone. Recursing.
Sir, just do
No.
check.
Keep it inside. Not required. Practice yourself. Come on, my dear. Keep it inside. You will not get that in the examination. Keep it inside. You are spoiling your own ability to do. Okay, how to start? Come on. From where you start? Writing the program. See, this programming practice is very important. You have a problem of writing program on your own. Come on, how to do this? First, you start with dot small. Start with the dot small. Dot model small. Okay, and then
Dot stack 100.
if you want to, all these things does not carry any marks when you write this in the examination. Okay, maybe half marks, 1 marks. Okay, don't claim any marks just by writing all these simple things without writing any code. The code part is very important. Okay, so dot data, this is very important. Whatever you write after dot data is very important, because this is the data declaration. Can you tell me what are the data declarations here? Come on, you have location 1. See, you have location 1. What is the type of location 1? DB, right? DB. Then what I should do? 10 data. You declare 10 data. I will declare 10 hexadecimal data. 20H, 21H, 22H, some 10 data. 1, 2, 3, 4, 5, 6. H is very important. 6, 7, 8, 2H. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will write one more here somewhere here. Okay. 2, 2H. Right? Okay, what is next? You have to declare location 2. Location 2. Location 2. How do you declare location 2?
Location to DUP question mark.
DUP time?
Question mark.
Question. Right. It is 10 DUP question mark. Yes or no? What is syntax? What is the correct syntax?
I don't think DB is there. I don't think
DB is there. DB is required. DB is very important. Okay. So this one, according to syntax, you are right. Okay. Then next. Next. What next?
nothing left.
It's enough.
Yeah,
Because location 1, location 2 is enough. If you declare it, it's enough. Okay. Fine. Then what next? Dot
code.
dot code. This is very important. Dot code start. Okay, what should come next? Tell me, come on.
Start and then move start comma and pick up.
Move ds ex comma
Add it.
move ax comma add data.
Then move here.
Then
DS
move
comma there.
ds comma ax. Okay. After that, tell me now.
उसके बाद now we will have to declare the index.
You are supposed to put the address of location 1. Okay. You can put it in SI register or any register. See here question is to copy the 10 bytes of memory location 1 to location 2 in the reverse order. Okay. So suppose, see what is the address of this? Address of this is location 1, right? So you can put move offset. You can write either move si comma offset of location 1, or you can use this also. Load effective address si comma location 1. What it does, tell me? The effective address, the offset address of location 1 will be available in SI. Have you understood this? Okay. Now, can you do same thing? Load effective address of location 2 to DI? Yes or no? Let the destination to be in the DI. I have understood this. Okay. Now you have to tell me what logic you are going to use. Is this DI has to start from the starting of the location? No, right? You have to put from the end of the location, the reverse order.
No.
Right? In the reverse order. How do you put it in the reverse order? See, this DI is correct. How do you put this? From where you have to start copying the data from location 1 to location 2. Then right, then what should happen to the SI? Exactly. Add DI comma SI. Exactly. Add SI comma come on. Add SI comma. You can do it in many ways. This you can do it in many ways. Okay. Add SI comma not 10H. SI comma 0AH. What is this? 0AH. Now where the SI is pointing to? SI is pointing to the last location. Have understood this? SI is pointing to the last location. Okay. Now what next? What next? You have to now copy. How do you copy it now? Move AL, comma SI. Move AL, comma SI. Right? Listen to this. Okay, later you can discuss. Okay, move SI, comma AL. Now, where the AL should go? Where the content of AL should go? Reverse order. You have to put it in the reverse order in DI, right? Location 2. Location 2 is pointed by DI. Okay, now what should do? Move. Come on, tell me. Move DI, comma AL. Now can you tell me which one you have to increment, or which one you have to increment, which one you have to decrement?
SI will be incremented, DI will be incremented.
So you have to decrement DI or decrement SI. You have to decrement SI because SI is pointing to the last location now, because you are trying to put it in the reverse direction. So decrement SI, then tell me, I will write it here. Decrement SI, after that increment DI, yes or no? Increment DI. Increment DI. Okay, what next? Loop. To do the loop, what you should do?
First write.
So I will just put a loop counter here. I'll put loop counter. What is the loop counter? CX, comma
10.
Fine. Okay. Should I use loop or should I use decrement CX? You can use loop statement here. See, loop up. Where it should go? Where up should go? It should go here. Loop up. Okay? Done? Yes or no? It is done. What next? After the loop, what it should do? It should terminate, right? Terminating means interrupt 3. Okay? So you will have to put end start. That's all. This is the answer for this question. Right? This way you have to write the program. Right? This is the answer for this question. Can't you write it this way instead of program? Start practicing programs, small programs, then go for a bigger programs. This is the answer for this. It's put in the reverse order. See, SI is pointing to the last location. From last location, it will put it to the first location of location 2. See, location 1 is pointed by SI. Location 2 is pointed by DI. Right? Now, in the program, we are pointing the location SI to the last location by adding 10 to that. Right? By adding 10 to that. Okay. Now, what it will do, see, it works like this. Just listen carefully here. It works like this. See here. This is one location. Okay. This is location 1. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is location 1. This is location 2. Location 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This is pointed by what? SI. This is pointed by DI. Right? Now, SI, we are adding 10 to this so that it will be pointing to this location. Right? We are adding 10 to SI, it's pointing to this location. DI remains same. What we are doing? We are, this statement, move AL, comma, SI, okay, move DI, comma AL. What this does? It will put the content of SI, this content, last content. It will move it to AL register first. Okay, and from AL register it will copy to DI. Where DI is pointing? Your SI is pointing here. Your DI is pointing here. So it will move the data to this location. Next, you decrement SI. Moment you decrement SI, it will be pointing to this place. Increment DI, it will be pointing to this place. Once again, the next loop iteration, it will copy this to here. So it will continue doing this how many times? 10 times until it puts the first data into the last location. Okay, go to the second program. Come on, this I have already done. Write a program to find largest number in the block of data. The length of the block is 0AH. Store the maximum value in the location result. This is done in the class. Hope you remember. Right? Second program. Second program is already done in the class. Do you remember how to do this? I have done in the class. I am not going to do it once again. Okay, refer to that, whatever we have done. Okay. Let us go to the third program. Let us go to the third program. Okay, what is the third program? Write an ALP. This I have done. Yes or no? This I have done in the class. Okay. So how to do this? Find the maximum. Compare instruction. Yes or no? Compare instruction. You can use compare instruction. Right. So logic is very simple. See, you have these 10 numbers in an array. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers are there in the array. Okay. You point it by some pointer SI. Right. Suppose if this is called as array 1. So what you do? Load effective address in SI, comma array 1. Okay, what it does? Its offset address is loaded into the register SI. It is pointed by SI register now. Okay, now what you do? You compare. See, this is the first value. You put this in the move first element. It is pointing here. Put the first element into the AL register. Right? This will be going to AL register now. Right? Now you have to compare these two, right? You have to compare these two. So what you do? Compare AL, comma, SI plus 1. Yes or no? Compare AL, comma, SI plus 1. Okay, now what you do? You have to check the carry, yes or no? If the carry is generated, what is the meaning of this? When you compare this element, which is in AL register, and next element SI plus 1, can you tell me what will carry will be generated, right? Compare instruction, you know. What is compare instruction? According to compare instruction, it is not going to store any value in AL. It is just going to show any changes happening in the flag register, especially carry 0 flag. Right? Now, if this number is greater than second number, is there any carry generated? No. Right? Now, if this number is less than second number, this compare AL, SI plus 1 will generate a carry. So, when there is no carry, what you should do? When there is carry, what you should do?
You can have a joystick.
Get the next logic to me. See, compare AL, this value, first value, compare AL, comma, SI plus 1. SI plus 1 means this one. It is comparing these two values. When you compare these two values, okay, so what should remain in AL? And, okay, so when the number should remain in AL, when the number of AL and SI plus 1 should be swapped. Because AL, consider always AL is going to have a maximum number. Right? Consider AL is going to have maximum number. Okay. So this is the max number now. First number is the max number. Okay. When you compare max number with the next number, right? If there is no carry generated, it should remain as it is, right? Yes or no? Okay. So now what you should do? jump on no carry, what you should do? Suppose if there is no carry, what you should do? If there is no carry, simply increment, right? You just see, you give a label x1. What you should do in x1? What you should do in x1? Exactly, increment SI. Increment SI. Suppose if there is a carry, what you should do? It should do move AL comma SI plus 1. Now tell me what the AL is holding now? AL is holding the max value. Right? If this value is less than this value, that means this is max, right? Then you change the max. Have you understood now? Right? Yes or no? Okay. Now tell me what is next? What is next? Increment SI you have done, right? You have to put a loop. Now I'll put something into CL register. How many? 10 into CL register. Decrement CL. Jump on no 0. Up. Where I should go now? Is it move? Compare. You should come here. Your up should come here. Your label should come here. Your label should come here. Up. Up. Understood this? Can you tell me, is it going to work exactly as required? Is the loop count has to be exactly 10? Execute this program. I want you to execute this program and tell me whether it is exactly works according to our requirement. Right? Take down this program. Execute this program. Right? And tell me it gets exactly the max number. I want you to do this. This you can do it, right? After that, okay, can you tell me what you should do afterwards according to the question? So you have to move content of the max value. The max value you should do loaded to the result. After that, done. Interrupt 3. That's all. Execute all these programs, okay? Execute all these programs. Have you installed emulator 8086 in your system, in your laptop? How many of you installed this? How many of you installed this? This is a very good simulator. It's called emulator for 8086. You can see everything in one screen. How many of you tried it? You tried it? It's very good compared to your turbo assembler. This is very good. I will demonstrate this on Monday. This one on Monday. Right? You type in the program. Type in complete program and execute. See, that's the way you can learn programming. Otherwise, you cannot learn programming. Have you understood this? You cannot learn programming otherwise. Right? Okay.
Sir, I have one question. So what happens to the carry flag if the contents of AL register and SI plus 1 are equal?
Equal, it will be 0.
What about the case when the AL is lesser than SI plus 1?
If AL is less than 1, carry will be generated. Okay? If AL is greater than the next value, no carry generated. Right? If numbers are equal, okay, then it won't show in the carry, but it will be shown in the 0 flag. 0 flag will be set. I understood your doubt. Suppose if two numbers are same, right? So what it will do, it won't, see here it will directly, there is a problem over there, right? If number is same, here we have to assume that numbers are not same. Right? See what this program will do, jump on no carry x1. If the number is same, suppose number is same, what will happen? It won't be affected in carry, right? right? So the best way in this case to use other jump instruction, jump above or equal. This is where that instruction comes. So how can you replace this now? Can you replace this with the other statement? Very good. Jump above or equal.
Sir, but again here it doesn't segregate the case.
Jump above or equal. If jump above or equal means it will check whether this number is higher than this number, okay? And also it will check when this number is equal to this number. When this number is equal to this number, this itself is highest value, right? So best fit for this program is jump above or equal instead of jump on no carry, right? Sometimes in an array, all numbers are not different, right? Some numbers are equal. In such cases also you have to check. That's why we use jump above or equal. Understood now? Okay? Good question. Nobody asked except one student.
So shouldn't we start the count value with 9 instead of 10?
Exactly. Because see, you are actually you're counting, you are actually starting from here, right? You're taking next. Every time what it will do, every location will be compared by the +1. What happens when it comes to this point? It will compare with this one, right? Is there any data there? No. Your count value will be 1 less than the total count. That's why what will be the count here? It is 0, 9. Now it will work. Good. Okay. Now, can you go for the third program? Can we go for the third program? Write an ALP to count number of vowels in the array of character. This is very interesting program. Right. Number of vowels in the, so every time it has to compare. Right? Fine. Okay. So how do you start this program? How do you start the program? I'm not going to write all those things in the beginning. Dot small. Declaration also I'm not going to do. Okay, how do you declare this data? You have that array, character array, DB. You can just put it as bits Pilani Dubai. Bits Pilani Dubai. How many vowels are there? You have some vowels in this, right? Okay, no problem, don't worry. Okay, assume that length of the text. Okay, see here length of the text is not given. You can fix length of the text. Okay, there is another way to do this. Let us go for the simplest one. Okay, now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There 15 are there. Okay, count will be, let the count be 15. Okay, now next. I'll directly go to the dot code, okay? Whatever is required, you can add start. As usual, 2 statements, right? Okay, what is the first statement? How do you access the array element? You have to use a pointer, right? Okay, you can put the offset address to some pointer. You can do it like that, okay? So you can put load effective address of array1, array into the SI register. Now SI register is pointing to the first element. Okay. What you should do with that first element now? You are taking the first character. Assume that it's only either upper character or lower character. Okay. This one, assume that it is either upper or lower character. Okay. Now let us consider upper character. Okay. Because if you are going for both lower and upper character, then you have to check for both lower and upper character every time in the program.
So when I get questions like this, we are allowed to use string instructions, right?
Pardon?
So we can use string instructions.
Of course, you can use string instruction. Of course, that's great. You can use string instruction. Okay. To use string instruction, this is required. Okay, this is required. Okay, so what do you do next? But string instruction, the problem with the string instruction, I will tell you the usage of string instruction here. See here, if it is a monotonous operation, string instruction is better. Here, your first character, every character has to be compared with A, I, O, U, E, right? There is no statement to compare with all this. That's why it is better not to use string statement for this. Understood? You can use it, okay, but you're not going to get much savings of code if you use a string instruction. I will tell you the difference between both. First, I will write conventional program. Then I will tell you where and all you can insert string instruction so that you can reduce the length of the program.
So
right?
between LASI is LASI offset array. We're trying to get the
No. That is move. If you are using move SI offset of array, I'm not using move instruction. See, there is one more instruction equivalent to this move SI, right? Offset of array. Both does the same thing. Both does the same thing, right? You can use any one. It is left to you which one you are going to use. Okay. So don't get confused between these two, which is very important. Okay. Fine. Okay. Next. What next? Move. Put it in AL register. You have to compare, right? Put it in AL register. What this will do? Tell me. You are moving the data from memory to the AL register. Okay. Next, what you do? Compare AL, comma. Yeah. You can put it like this. No problem. Either you can write the ASCII value, compare AL, comma ASCII value of A, or else you can put A in the A between the quote. This you can do. No problem. Okay. What will happen now? If it is not an oval, okay, what it should do? It should go down and increment the SI and try the next value. Yes or no? Yes or no? Come on. Right? See, it's not that you compare it to only A. Right? What it should happen? Tell me.
5 cases.
If there is a result, if it is true, it has to increment the count value, right? You have to put a count value, right, for this. See, what is the question here? Question here is to count the number of vowels, right? Number of vowels. So that means you need a counter, yes or no? So what I will do, I'll put a counter here. Move, I'll put a counter as some BL. Move BL, comma 00. Let us start from 00. Right. Okay, now what is the next statement? Compare AL, comma A. See, it has to compare with all the vowels, right? Somewhere it matches with one vowel, means you increment the counter and go to the next SI. Yes or no? Right? If it is not an vowel at all, right? If it is not an vowel at all, then what it should do? It should directly increment the SI register, right? And start with the next. That's what it should do, right? See, if this is not, I'm going to write the last statement here, okay? If it is not an vowel, see, it has to compare with all A, I, O, U, right? See, if it is compared with this, then you compare it with the E, O, U. Have understood this? Okay. Now, every time you do some checking, right? Right. What you should check? Come on. Think about it. I want you to think about it. My dear, you are sleeping. I don't know. It's better not to come to the class. Right? Make use of the class. Right? Okay, what is the next statement? Think about it. Think about it. Add? Is it add instruction? Which flag is important for us here now? Zero flag, right? Zero flag is very important. Okay, so what I should do if the flag is zero? So jump on zero. Okay, where it should go? Where it should go? I will put x1. Where x1 has to be increment BL. Right? If the result is not zero, it will come to the next statement, right? What you should do here? Compare AL comma E. I'm just trying to take only capital letters, okay? If you want to do it with the small, same, repeat it with the small letters. That's all. Copy and paste. Only changes that only A. Okay. Next, what you do here? Suppose if the result is 0, where it should go? X1. X1. Right. Okay, next. What should it should do? Compare L comma I. Right. Now tell me where I should do increment SI.
All the cases are there.
Okay, after all the cases, so anyway, you have written x1 increment BL here, right? If it has not found any of the vowels, it should simply increment the SI register and it should go up. It should go up. Okay, so where you are going to put that? Here in this.
Jump instruction at the end to go directly. In the x1.
Are you going to use simple unconditional jump? I told you that never use the unconditional jump, always.
Jump to 0, last case. The last
Where the last case will come?
the O case.
Okay, for example, O case will come, last case. Okay, so then you have jump on 0. After jump on 0, it will go to increment. Because your increment SI should come after this. Yes or no? It should come after this, right? Okay, so your increment SI should come here. Right? Now, after the last case, okay, it will go to the x1 and increment. Right? Suppose if that is not satisfied, it will go to the next. Yes or no? That is your increment SI. Right? So last you will have increment SI. Okay, next what is next? Loop up. Where your loop up should go? Move AL comma SI. So what it will do, every time it will take one character in SI, compare with all the vowels. If it matches with the vowel, that means this will be satisfied. It will come to x1, increment BL, then increment SI, come like this. If it is not a vowel at all, what it will do? It will skip the next statement. It will come here. But just check here. This part is very tricky, right? See, suppose imagine that this is the last you are checking. Jump on 0. You are making x1, right? Right. So if the result is not 0, the result is 0, it will come here. Suppose if it is not satisfied any one of this, now see it is coming to this statement. Is it a correct way of doing? It is still increment, right? Okay, how to change this? And jump here. What you should do jump here?
Jump x2 fixing that increment. Or you could move the x2 statement before up here.
Jump x2. This is x2, right? Will it solve the problem? jump x2. Okay, so that means if this is not satisfied, it will come here, right? Then increment si and it will continue. You can do this, no problem. Right? Jump x2. So what it will do? If this is not satisfied, it will come here, right? But it should not increment BL, yes or no? If it increment BL means it is for non-OL also it is incrementing. That's why if you jump x2, then x2 will come here. In such cases, it will just simply increment si and it will just. You understood this, okay? You try to execute this program. You write yourself. You type yourself program, okay? You type yourself. That's all. Of course, I have to half program here. You have to complete yourself. Fine, okay? So we have done 3 programs today. So try to